General RCC building modeling and designing. So let us start with a demonstration in which this is going to be our RC building model. So let us go to the MIDAS Gen software solution. This is the start page of the software. So let us start with a new file. So after registration, using this icon, you can go and click on the new file and see whether the registration has been successfully done. So as you can see in this user interface, we have got two tree menus, not just one. We can of course have only one if you require more space. Then we have got a message window at the bottom of the screen, and at the end we have this line in which we have got units which we can change at any point of time, pre-analysis and post-analysis also. Then there are some selection options by direction. So we'll be seeing and using all these options one by one during the demonstration. So let us start with the structure. These tabs are according to the direction, like the way we have to construct the building. So let's start with the structure type. So the structure type, we are doing 3D analysis. Then the mass control parameter will be lumped mass. We'll use the static seismic loads in which the self-weight is converted into masses. For panel zone effect, that is if you want to consider the rigidity of the connection between beams and columns, then that panel zone effect can also be taken into consideration using this option. Okay, so let us now start with some properties first. We'll define material properties. So we have a huge database of steel and concrete according to ISRC. So different grades are available over here, and in the same file we can have more than one grade of concrete assigned to different elements. So let's take M30, M35, M40 as grades. Now we can also here go for the section properties. We'll create some sections, add. So again, a huge database for steel sections or any type of section. So we can have solid rectangular section for now. Let's create podium columns, as the structure is having a podium and 13-storied building and roof. So podium columns user defined. Let's have these columns as 0.45 meter by 0.45. Apply. So at any point of time, like I said, if you want to give the section sizes into meters, into mm, so you can change it into mm. Section properties, add rectangular section. Let's say I want main building columns here. This will be user defined. Now this is in mm. We need to understand and see every time what is the unit and then input the values. So let's take it as say 800 by 300 mm thickness. Say apply, and I'll create some beams. The beam size, let's say, is 700 by 230 mm. Okay, so we have created 3 sections. Also, if you have some predefined sections, you can import it from other files. Now let us define some thickness for the walls. We'll create some walls also. So then over here you see there is in plane and out of plane option, and in plane different thickness, out of plane different thickness options are available over here. So let us take first the in plane and out of plane, the same section thickness 230 mm. Okay. So I'm just converting back into meters so that confusion won't happen in providing the distances. So let us start with our modeling. So we'll start with the node element option. We'll first create a node. So as we can see over here, the coordinates x, y, z. So before starting, let me tell you that the xy plane is the horizontal plane in MIDAS Gen, and z is the vertical distance. So let us apply. As we can see over here, one node has been generated. These are all selection options. This can select all types of elements. So we'll be seeing one by one what all these selection options do and how they are useful. Okay, so now we created one node. Let us use the extrude option and create the beams. So we have got this extrude option in which nodes can be converted into line elements, line can be converted to planar, and planar can be converted into solid elements. So using M30 material, then checking the section, that is beams. Now I want to create at 4 meter distance some 14 number of beams. I say apply. There are some display options which you can change. Now this has been, this we can see in red color. We can go in the display option and have a random color by section. In this way I can change the color, even the font size of the display. Okay, now again let us select all. This is a select all option. I'm selecting all the nodes. Now I want to make certain beams in the y direction. So we'll take the unequal distance in the y direction. And now let me tell you how this unequal distances can be applied. So let's say I want 2 beams at 4 meters apart. Then I want a 6 meter beam, a 4 meter beam, then again a 6 meter, and again 2 at 4 meters apart. And I say apply. So as you can see over here, the beams in the y direction have been created. Now let's go in the top view, select these, and using the translate command, I will copy these beams in the y direction. We'll do it in the unequal y direction, same as that we had done for the extrude. 6, 4, 6, 2 at 4 meters apart. I'll intersect, save side, the nodes and elements, and copy the node and element attributes and apply. So we can see over here a podium plan has been created. Now let us extrude the columns. So now I'm here using the extrude option. I use a select single. Now select single is using the cursor by dragging. Then there is select by window, where one click, as in the window is created by using 2 clicks. So I'll just select the nodes. Over here the elements are also selected, but only the nodes will be taken into consideration, as we are extruding only the node elements into the line elements. So let's change the material to, let's say, M35 podium columns. This will be in the Z direction, vertically downwards, so -3, and apply. So in this 3D we can see over here our columns have been generated. Now let us extrude the line elements as wall elements. Now over here we have option of plate and wall. Plates can be used for slabs, and for designing a wall, a shear wall, we need to create a wall type element. So this wall type element by default is taken as membrane. You can convert it into plate for taking the bending moments out of plane. So let's see. We are going to select the beams. Let's take these beams. These will be converted into walls. This I will not select because we are going to further divide it and create more walls. This will be again in the -3. Section thickness is given only 1, but we can select if we have given multiple numbers, I mean section sizes. So now we can see over here our walls have been created. Yeah, so I was saying that we need to do some dividing of beams and then create by extruding those beams into columns, into walls. So let me just divide this into equal distance 2. So 2 equal distance have been created. Now I want to divide these 2 beams into unequal distances in x direction. This is local x. So I wanted 2 meters. Okay, and I'll also create a beam in between them. These are the lift wells that I'm creating over here. So using this ortho option, I can also create a beam that is perpendicular to this beam created over here. Okay, so now let me just select these beams and using the extrude option from line element to planar element, that is I'm 30 and -3 direction. This will be a wall element and apply. So now we are done with the wall elements. We'll create some building columns as well. So let us select the nodes which are to be converted into beam building columns. Let's go to extrude as we are already there. Now selecting M40, building columns, -3 and apply. So you can see over here our columns are completely generated. So our our floor has been completely generated. Let us go to the structures and translate this, or rather copy this ahead. This will be ones at 3 meters. I say add. Then these material increment, column section increment, these all increments are according to the section sizes and the thicknesses and the material properties that you have given during the property definitions. So if you click on one, then whichever is the next property, that will be taken into consideration for the next floor that is created. So again, I'm using over here the select all option. Okay, and I say apply. So our second story has been generated. Now let us create the main building. So I'm now selecting only the middle portion, which is going to be generated upwards into a 13-story building. Now using these activate options over here, I'll say activate only. So let us deactivate the lower story. So using this deactivate option or inactivate option, I've inactivated it. Let us select all and increase the number of copies. Distance going to be 3 in vertical direction, and I say add over here. We do not want this, and I say apply. So now we can see over here, if we say activate all option, our entire building has been generated. Okay, so this was about using our normal basic functions of creating the node and node and elements. Let us go ahead with creating the boundary. That is, we have to define the supports. We'll go in the front view, or you can use the option select by plane, in which XY plane, that is the horizontal plane. So whatever nodes elements come into that plane will be selected. So as you can see over here, those nodes have been selected lying in that particular plane of that particular node or position that I have given. Okay, so this is over here about the definition of supports. So this is directional all, as in all will be fixed directionally, and rotational all, that is moments, will be fixed. We have got 7 DOF over here, degrees of freedom over here. The last one is the warping effect. So now supports have been defined. Also let me tell you about the beam and release option that we have over here in case you want to define. I mean, there are no second and tertiary beams created over here, but when there are and you want to define the path of the force transfer, then you can create the beam and releases. We have panel zone effect over here, in which the consideration of the rigid, the highly rigid area of the beam and column connection is taken into consideration, and the moments are shown likewise. Then the diaphragm disconnect option is there. So let me first go back to the structure, go to the story and say auto generate. Let's create the stories. Okay, so when we create the stories, the floor diaphragm is automatically considered. So now that this is done, we'll also make the auto wall ID generation with all the walls. I'm applying it for all the walls. Yeah, so let us go back to the boundary now. The diaphragm disconnect option is available where the openings are there and you do not want to consider that part of rigidity. In the display option, you can go to boundaries and see the story diaphragm. So as you can see over here, the story diaphragms are visualized. So let us go ahead now with the loading. We'll do the static and dynamic loading in this basic tutorial or technical webinar session. So static loads, first we will create the static load cases, in which let us consider the self weight as dead load. Add, let us consider superimpose dead load, some live load function. The type will be live load. We'll create one earthquake force, earthquake, and we'll create wind load on structure. This can be done in the X and Y direction, negative, positive. We'll see that further. So the first thing we need to do is give the self weight command. In the self weight command over here, we see that there is option of X, Y, Z. So we have to give the software command if the where the gravity is actually pulling towards the X, Y or Z direction. In our case, we have Z direction, that too in the negative direction. So these are absolute values where we have to provide it -1. So let's say add. Now this is not assigned as such to elements. It is already automatically assigned to all the elements that are modeled in the file. Okay, so let us go ahead with the wall loads. Okay, let us consider the wall loads as self weight only, because these are going to be there. Okay, I'm going to now use this work stream menu to select all my beams. I just double clicked on it. Okay, I'm adding, let's say, -10.6 full wall height. I say add. So now my wall load has been done in the UDL format. Also there are various other options in the load types, like we can put concentrated force, concentrated moments, trapezoidal loads, and likewise. Now let us go ahead and create the floor loads. Now for creating floor loads, we need to first create the type. Okay, so let's go for the define floor load type. So let's make it a podium level or podium floor in which my sulfate is going to be high. I'm using higher thickness, let's say minus 3.75. My superimposed dead load will be minus 1.5 say, and let's say I have got some vehicles there, so let's put it as minus 5, and I say add. Next, for a typical story or typical slabs, my sulfate goes down to somewhat 2.75 depending upon the normal thickness of the slab you want to take. SIDL, let's keep it as minus 1.5, and LL, that is a live load, let's take it as minus 2. So over here we need to be careful about putting the sign conventions, that is in the negative direction. The software is FEM based, so we need to consider and understand what input we are giving to it. Now let us create one more, let's say a roof level, and I'll increase the live load as 3 and SIDL as 3 again with some waterproofing. Okay, so now we are going to be applying these loads. There is this activate option by identity, that is by story we can do it. Now we have defined the stories. Let us activate only the floor. Okay. Now using just this one plan, I'm going to be creating the floor loads for entire building. So let us see how. So at the podium level, these are the distribution ways where we can do one-way, two-way, polygonal centroid when there are more than 4 beams. Then polygonal length, where more number of beams are available in the convex direction also. So we'll see that in some advanced tutorials also. We'll right now take only the two-way distribution, and I will show how easy it is to apply. Now there are two floors of podium, so we'll copy it in the Z direction with the distance of 3 meters. Okay, so now just click on this green tab, and now I start just using 4 nodes, and whatever beams are coming in between, the load will be distributed accordingly. Okay, so we are done with the podium level. Now let us do for the typical level. Now this typical level, this is 13 numbers at 3 meters height. So let me select. So my walls are there. I do not need to create any dummy beams for the walls, for the floor loads to be created. The walls will take the distributed load. So I'll just activate all, and we can see over here that all the stories have got the generation. Now let us select the last floor, roof level, activate, and I'll create the roof level floor. We will not copy it, there is no further story about it. The software gives us errors and warnings while giving the commands itself. So later on during analysis, issues don't happen. Okay, so now our floor loads are done. Let us go ahead with the lateral loads, that is the wind loads. Now I'm assuming this structure to be there at Pune, so I'm considering IS 875 standard method. I'm considering the basic wind speed as 47 meter per second, terrain category as 3, building class as C, and I'm going to apply it only in the X direction. So my Y will be 0. Apply. So now I'll show you the wind load profile. Before analysis itself, we will get all the story forces, story shears, overturning moment graphs, and the entire calculations over here itself. This calculation sheet we can readily get over here before analysis and understand what calculations the software has done, what forces, what shear forces have been taken into consideration, how they are calculated. So for every story with the X, Y, and Z direction and all any parameters, all the parameters that have been taken according to the IS code. This can be saved. Similarly, we see in the seismic loads, add earthquake using IS 1893. So let us take this as seismic zone 3, medium soil, importance factor 1, damping percentage 5. Now the fundamental period we can manually input over here using calculations, manual calculations, or there is a period calculator available in MIDAS Gen. So these are all formulae that have been provided as per the IS code. So let's take the infill walls and apply. So it has calculated the X and Y direction by fundamental periods. Now let us give it a direction. I'm putting it in the X direction only, so Y direction 0. We can apply the accidental eccentricities. So that is what EQX positive, EQX negative. So that is dependent on the accidental eccentricity, the vertical moments that are applied. So I'm not applying any vertical moments as such for now. Apply. Again, just like we have seen in the wind load, there is a seismic load calculation sheet. So before the analysis itself, we can see the shear, story shear, base shear 2562. So let us just note down this number because we are going to be doing the response spectrum analysis over here. So for the scale factor, we need to remember this number. So now we are done with the lateral static loads. We'll go ahead with the dynamic loads. So response function, response spectrum data, that is what we're going to define now. Function, add. So we have data for design spectrum using again the IS 1893, selecting the seismic zone, soil type, damping ratios, importance factors, response factors, and the maximum period will be 6. So we can see this graph with normalized acceleration, velocity, likewise. So our RS function is done. We'll create the load cases now. Let's make it in the X direction. Spec X. So excitation angle, I'm keeping it 0. That will be in X direction. For spec Y, we'll be keeping it as 90 degrees. Now if the structure is not exactly rectangular, we do not know which is the major axis where the maximum loads will be applied, that time the auto search angle will be seen. So X is the major angle over here. We'll see, I'll just show in the later results. Let's add it. We have to do eigenvalue analysis to understand the natural period of the structure. So there are two types, eigenvectors and Ritz vectors. So for complex structures, Ritz vectors are used. Let us use for a simple structure eigenvectors itself using either the subspace iteration or the Langsource method. Here I'll be using Langsource method. Let's have the number of frequencies, let's say 20. Okay. Now I'm just putting a spec common one where I wanted to auto search the angle, the major angle. No scale factors are required to be provided at the beginning. Add. So now we are done with the response spectrum data. We require to do one load to masses command. So my dead load's going to be 100% and my live load will be 0.25, as my live load is for a basic structure, not important one. Or rather, according to the code, it says that if the live load is taken 3 or more than that, sorry, 5 or more than that, then your loads to masses conversion of live load is supposed to be 50%. So now the loads to masses is done. We'll go ahead with the analysis. So within short period of time, our analysis has been completed. This is the analysis message and the command message. Also, let me tell you about the modeling part, that you can give commands like you give in AutoCAD in MIDAS Gen as well for creating any modeling part. Now, after analysis, let us go ahead and see the results. So after analysis in the results tab, we'll first create the load combinations. These load combinations can be automatically generated by the software. So we'll go to the concrete design, as we'll be seeing the design part also today. We'll add concrete IS456. Now we need to put the scale up factors spec X and spec, the simple spec automatically generated. So for that we need to understand the scale factor. So where to see the scale factor? So in the results table, as we see over here, let's go to the story and see the story shared by response spectrum analysis. We'll see for the spec X and the simple spec. So we can see the base shear over here in the X direction is 3354.5. Yeah. And it is the same as that in the spec X. Okay, so now likewise we have to apply the scale factor. So let's say it comes to somewhat .57, somewhat. This is pre-calculated value. I guess we need to calculate it again. So let us consider it. And we can see over here the strength and serviceability load combinations have been created with the scale factors that have been applied. Okay, so let us first see with the reactions of the columns. So let us take a load combination of dead load plus live load. I will activate by this. We'll see the values apply only in the FZ direction. Okay, so now we can see over here a red arrow is marked over here. This means that the maximum load or a maximum reaction is coming at this particular node, and the values also can be visualized over here. Next, we'll see the deformation or the displacement contour of the entire building. So we'll see the same. We'll deform it. Let us not apply the values. Okay, so this is how we can see the deformation and the legend also over here. Let us go ahead and see the SFD BMD diagrams. So let's see in the forces beam diagrams command over here. Let us undeform it. Legend is seen. So now we can just activate only a few columns and beams for seeing a proper view. You can have a solid fill. See the values. So we can see the maximum values, or we can see all the values at the same time. Plus there is a quick view option. So let me just activate all. Okay. So I'm taking any beam over here. So this is a quick view option in which any beam can be clicked on or any element can be clicked on. Select any of your load case, any of the component that you require to see. And at any location. Also we have got this beam detail analysis option in which any beam can be selected. And you can see the displacement diagram, SFD and the BMD. So this was about the force beam diagrams. We can also see the wall diagrams. So whatever the walls we have created, so their moment diagrams is also seen over here. We can just select only the walls and activate. So this is done. We'll go ahead and see the mode shapes, vibration mode shape. I'll activate all. This is the initial view. So we can see the multiple mode shapes, how the structure is deforming and behavior of the structure. So now to see ahead, the vibration mode shape tables are there. So the eigenvalues, if you want to check, just select all of them. We need to see the modal mass participation. So here we can see them. So we need to note that at the 11th mode itself, the mass participation is more than 90%. So these are the results in whatever results we get in the table format. These can be dynamic reported, or we can take it to the Excel sheets as well. There are, like most of the options over here, they work for only seeing the spring reactions or without spring reactions, like that. So it can be changed manually. So let us go ahead now with the design part. So design, we have got options of steel design, RC, SRC, cold form design, but in IS code we have got just steel and RC design. So we have selected right now IS 456 RC design. In the general parameters, I'll show first the definition of frame. It is going to be braced. Secondly, important is the member assignment. So the secondary and tertiary beams, if there are, so you can use the automatic and say all option, and it will automatically understand the load transfer that we have provided using release option. and accordingly the design will be done. Now let us start with the design code for the RC design. We have selected IS 456. We can apply the IS 13920-1993. Then the safety factors of the soil change. We can change the modulus of subgrade reaction, distribution factors for beams. This also can be changed over here itself. So if you want 30% of the moment radius distribution, then 0.7 then modify concrete material. Now we need to provide it with the steel grade, the reinforcement grade. So I'm just going to use the IS grade of 500, Fe500, and we can see over here the compressive strength. All these things, they can be changed, and manual FCK can be provided by just saying none and say modify. Similarly, these options are important. Next part is about the design criteria for rebar, where we'll be giving the software the options for using the number of rebars. So according to the IS code, these are the accordingly 50% or 100%. Then for column design, again selection of the bars, the links, and the cover for the column, let's say 40 mm. Then there are no braces. Let's go ahead for the shear wall design. Rebar, let's say only 12 mm diameter, horizontal as 10 mm. Then the cover, let's take as 0.25 mm only. Then there is input additional wall data, in which we can also design as out of plane bending, and we can check with the spacings of the vertical bars. So we do not want it to be spaced so much, and we need to add certain. We can manually input also. And there are different methods. You can see it in the help menu. Okay, so now we are done with the design criteria for rebar. Moment redistribution factor we already provided. Now let us start with our beam design. So now all these beams, instead of that, because of time constraint, I'll just select a story and beam design. Okay, so now our beams have been designed. So we can see it according to the properties that we have given to the beams and the members also individually. So I'll just activate this story for us to have a better visualization. We'll connect this to the model view. So we're talking about this beam over here. We'll see the graphics by clicking over here. This shows us how the reinforcement has been placed, how much reinforcement has been provided. This is a short summary. Then we'll see the detail, how the beam design has been done, which load cases has been taken, what formula has been used, shear capacity. So everything, detailed report you can get. Also, we can get a small summary in a table format over here. This table can be copied using this copy table and pasted wherever you wish to. So let me explain this. We can see over here the position IMJ, start, middle, end, the negative moment that has come, the load combination that has been taken, the maximum load. Then this is the top steel area of top steel, the rebar arrangement, that is 2 bars of 16 mm diameter. Then the positive moment, the load combination for that, and accordingly the bottom area reinforcement. The rebar positioning, 4 numbers of 16 mm diameter. Then this is the shear force, the load combination for them, the area of this shear force, and the stirrups that have been taken at different positions. We can again see it by saying which are the okay, as in which are the past ones, which are the not good, as in the failed ones. Over here none of them failed, so we'll see ahead if it happens in the columns. I'll just say all. Select few columns over here and let's say column design. So again similarly I'll select the podium columns also. Yeah, so now you can see over here by property the podium columns and the building columns. So in the property itself we see whichever has failed, but none of the columns over here has failed. In the member, again let us activate this and connect the model view. So this column we are talking about, let's see the graphic. In the graphics we'll see the arrangement of the bar that has been done. This rebar pattern, it says that there are 6 numbers of bars, 2 numbers of rows, and P20, there is 20 mm diameter. You can see over here the PM interaction diagram as well, the shear force capacity. Again, a small summary of the column design. We can get the details of the column design just like we had for the beams. So now if you have any column already designed, you can check that, or you need to provide some other arrangement. So let's select that and say update rebar. So when you say update rebar, over here a column has been generated. So you right click on this and say properties and detail figure. So over here you can change the number of rebars, change this, say add, replace, close, and this can be checked using the concrete code check, column checking. So this does pass. We can see the graphic over here. We had changed the number and diameter. So this is how column design, column check, beam design, beam check can be done. So I'll just activate all and show you lastly the wall design. So we need to be careful while creating the walls. It should not be a plate element. So we need to select the plate or the wall element while creating it. So now over here we can see the walls. All walls have not been have not been passed. Most of them have failed. So we can just see, click them and say graphic. And over here we can have a graphical presentation of how the design has been done. And we can see why it has failed in the actual and the moment. We can see the PM interaction diagram. It has even failed in the shear force capacity. So even the drop PM curve, if we click, 3D PM diagram can be seen over here with all the detailed result. We can even print these results. So in this way, we have seen beam, column and wall design in MIDAS Gen. Now lastly, we need to see the foundation isolated footing design. So for that, we have to go for the next software solution, that is MIDAS Design Plus. You go in the tools and click on Design Plus. Okay, so now we'll say new file. So actually MIDAS Design Plus is under development. Right now only footings are available, but as per American codes and Euro codes, and in future the Indian codes also will be included in this. Slabs, beams, columns, shear walls, footings also isolated, combined strip footing, then buttress, stairs, corbels, beam table, slab table, patch wall, even some steel designs can be done in MIDAS Design Plus. So let us select the Indian standards. Basically this IS 456-2000 for RCC. Say apply. Let us change the rebar code. I've just double clicked on it. IS. So all these footings will select. Then there are certain spacings we do not want, so we'll remove that. Apply. And preferences for designing, I want to change the maximum thickness. I wanted to design, so for that maximum thickness, let's take it as 1000 mm, 1 meter. So let us start with isolated footing. I have to connect this MIDAS Design Plus with the MIDAS Gen file. We get a confirmation over here that successfully linked with MIDAS Gen. So now I want to import the reactions from there to MIDAS Design Plus and then design it. So let us go to MIDAS Gen. Let us select certain, let's say I want to design the podium isolated footings. I've selected using select single option these nodes. So we can see over here these nodes are reflected. Okay, so I say import. So we can see the node number 121 is having the highest reaction values, the load values. So according to the design load and the load combination is taken over here. We need to consider what concrete material we are using for the footing, the main rebar, any surface loading if we want to apply to it, changing the soil bearing capacity, let's say 250, and I just click on design. So you can see over here 700 mm thickness is required and 2300 by 2100 is the rectangular footing that they have provided and how the results are. And this is what the result we'll see. Also, if you want to change anything, let's say I want it to have only 500 mm thickness, and check. So it is failing in the one way and one way shear in the X and Y direction. In a two-way shear it is passing. So we can see this in the various forms like say report. So if you have any queries regarding the webinar session, any feedback you would like to give, please write to us at techsupport@midasit.com. Thank you for attending the webinar. Have a great day.